Let's move on to the next section, which is 1.4, which is the distributive property, and that was given to the classes around this time, Thursday and Friday, August 25th and August 26th. So if you go over to the calendar on either of those days, you can actually look at the presentation. So you can just click on it and you can view it. You can't change the date or remove it. Only I can do that, but you can see what happens here. So here it is. You're going to go over to launch presentation. You're going to, if you want to, minimize it so that it stays within here. Sometimes we have problems with this. So this is actually a pretty common problem. So usually if you don't see anything appear right away because it's taking its sweet time, just go to the next resource and then go backwards and it'll pop things up. So we're going to look at some vocabulary. We have coefficients, like terms, simplest form, equivalent expressions. And so if you go over here, the coefficient is just something that goes in front of a variable. So a coefficient in this case would be a 5. The coefficient here would be a 3. And the coefficient here would be, if I can get my pen to work, which is, it is not, would be a negative 2x. Okay, so a negative 2. So then it would be a negative 2. So those are my coefficients. My terms are, if you look at this expression here, for example, so there's my expression that I have. And so my terms are each one of these. So here's a term, here's a term, here's a term, here's a term. So 3x squared, 2y minus 4, 4x. Those are my terms. If I want to simplify anything, then what I want to do is I want to combine these things called like terms. Now, like terms have to have the exact same variable, and it has to be to the exact same power. So notice we have a 2x, a negative 3x, and a 5x. I can combine all those together by adding and subtracting them. So I would do 2x, or 2 minus 3 plus 5. 2 minus 3 is negative 1, plus 5 is 4x. So there I would combine those together. Notice I have like terms here, 5 and 2, which have no variable. So those are considered like terms. 5 minus 2 is 3. And then I have my 2y, which is sitting right there. Now, had any of them been, 2x squared or anything like that, I cannot combine that with the 4x. There's no way to combine those two together because they're not like terms. And then the last thing is equivalent expressions. Just means that if I can figure out a way to write 7, 3 plus 4, that has to equal 5 plus 2, which has to equal 6 plus 1. That just means all these expressions here, this here is an expression. If it doesn't have an equal sign, this is an expression, this is an expression. All those expressions represent the same number. So that is equivalent expressions. Okay, so what we're going to be dealing with this time is the distributive property. The distributive property just allows me to multiply things to one side. Eventually, we're going to learn algebra tiles. We're not going to do that in this one, so I thought I had gotten rid of this particular one. We're going to move on to the next resource because we're going to go right to the distributive property dealing with numbers. When it says with numerical expressions, that means with expressions that only have numbers. So, for example, if I have 4 times 9 plus 3, I distribute it by multiplying 4 times 9, and then 4 plus 3. If I have 5 times 8 minus 2, I can distribute that by doing 5 times 8, and then 5 times negative 2, or negative 5 times 2, whichever way you want to think about it. So we do that, then we add everything up, and we take care of it. That's the distributive property. Okay, and I'm going to show really quickly as this is kind of coming up because I want to show the distributive property. So we have the distributive property. So if I have 5 times 6 minus 3 plus 1, I can do a couple of different things. I can either combine all these like terms and then multiply, or I can use the distributive property and I can multiply the 5 through to all the terms. So that would be 30 minus 15 plus 5, and then add them and subtract them all up and get a final answer. Okay, I can also do the distributive property on the other side, so I can move the 5 over here. These two things are called equivalent expressions, as I mentioned above. They get the same answer. I still distribute the 5 through. 5 times 6, 5 times -3, 5 times 1. Okay, and that's what this is talking about here. So now, in this case, we have $200 per person. We have 9 adults, 3 children. We want to find out what's the total cost. We're going to multiply 200 times the addition of the total number of people. So 200 times 9 plus 3, which is this one right here. I can distribute it. 200 times 9 is 1,800. 200 times 3 is 600. 1,800 plus 600 is 2,400. So the answer in this case would be D. Okay, so that's what we do with that. What assumptions did I make? That it was the cost for the same child and adult. Okay, here's something that you don't have to do, but it's a way to be able to solve problems a little bit more in your head. This is what is known as mental math. So if you have certain problems like this, let's say that we have a problem. I'm going to do an example before I do this one. Let's say for mental math that we have a problem which may seem kind of difficult to solve. So if I have 3 times 54, of course, then you're going to have to get out a calculator, or you're going to have to do it, this way, 54 times 3, which of course is fine. Or I can do this, 3 times 50 plus 4. Notice I changed 54 to an addition problem. And now I'm going to distribute. 3 times 5 is 15, so 3 times 50 is 150. And then 3 times 4 is 12, that is 162. So it's a little easier to do it in your head. So that's what we would do. So for mental math, for this one, 44 times 2.5. Well, first we have to remember how to write 2.5. So if I have this, I'm multiplying. That's the same thing as doing this. Okay, if you remember 2.5, 2.5 means 2 plus 1/2. Okay, so I changed it into a problem similar to this mentally. And so now 44 times 2 is 88. That's a little easy to do. 44 times 1/2, or half of 44, is 22. And now I have to add those two up. So when I add those two up, 20 plus 88 is 108, plus another 2 is 110. So I would get 110 in that particular case. So it should be, when we distribute, should be this one right here. Okay, so doesn't make any sense for any of the other ones. 44 times 2.5, that's kind of, that's true, but I would never throw a problem like that to you. Oh, okay, it didn't like this one. Oh, that uses the distributive property to rewrite. Never mind. So we would get rid of that one. There we go. Okay, that makes sense. Okay, so if we evaluate it, we did it. It's 110. And that would be it. So then we move on to the next one, which I think is our check. So this distributive property with numerical expressions you have to do. While you're doing that, you can prep for the next video after you're done, and then watch the next part up to the next check.